Hello students, today we deal with a very important concept, that is black body radiation. So before going to that explaining the black body radiation, we have to know what is mean by black body. Okay, so what is black body? So body means any object. For any object generally we take it as a body. So what is mean by this the black body means a perfect a perfect emitter and absorber of all types of radiations. Okay, so means so generally if normal objects, okay, normal all natural objects, when any light passed on them, they are able to accept, they are able to observe some type of radiations, and they are able to release some other type of radiations. Okay, means it is a characteristic property. It totally depends on the nature of that object, that it absorbs which type of radiations and it releases which type of radiations. It totally depends upon the nature of that object. But if an object is able to accept all type of the frequencies, all types of frequencies, nothing but all types of electromagnetic radiations, all type of radiations, and which is also able to release the all types of radiations. That is why it is known as a perfect emitter and a perfect absorber of electromagnetic radiations is called black body. Okay, so one other explanation is also given. So if any radiation is passed on it, it absorbs all the radiations, of all frequencies, and releases whatever the radiations are absorbed by it. అంటే అది ఎంత ఏ రేడియేషన్స్ మొత్తం అబ్జర్వ్ చేసిందో ఆ అబ్జర్వ్ చేసిన రేడియేషన్ కంప్లీట్గా ఏం చేస్తుంది, ఇట్ ఈస్ ఏబుల్ టు ఎమిట్ అవుట్. సో దట్ టైప్ ఆఫ్ ఆబ్జెక్ట్ ఈస్ కాల్డ్ black body. So a perfect emitter and absorber, a perfect emitter and absorber of radiations of all frequencies. All frequencies is called a black body. So here main important thing is, actually there is no perfect black body is there, but why we are discussing this means it is an imaginary one. That's why it is also called an ideal body. For example, we know the ideal gases in the states of matter. We discussed about the ideal gas, but is there any gas in the nature which shows 100% ideal behavior? No, not at all. In the same way, this black body is an ideal body. There is no such type of object is there which works as 100% black body. Okay, so we write the definition. So this is the one of the definition: a perfect emitter and absorber of all radiations. And we can give one more definition. So a body is capable of absorbing all types of radiations and emits completely the absorbed completely to the absorbed radiations. Is called black body. From now onwards we return the black body like B dot B, that is indicates BB. So, okay, so this is the about the simple definition of black body. So main important to have to remember, this is an ideal body. But is there an example is there which acts as a black body? Already we said in nature there is no object is there which works as 100% black body. But practically in nature it is not present. But we can do one thing, we can prepare one black body, but which is also not having 100% black body character, which is, we can say, it is near to the black body character. So what is that? The best example for black body we can prepare is, so first the main point we have to remember, BB. We know that black body is an ideal object. Okay, but so somewhat near. Okay, a hollow sphere. A hollow sphere means the sphere just like football. Okay, means inside the total it is vacant. A hollow sphere, and here it is coated inside. It is important. Coated inside with the platinum black. Coated inside with the platinum black, which is very dark like carbon, having a pinhole on it. So a hollow sphere. So we can't draw the sphere. Just just think it is a sphere coated inside with the platinum black, having a pinhole on it. Is works as a near to black body. Works as near to black body. For example, just this is the sphere. So inside it is totally coated. Inside it is totally coated with the platinum black. So this is a hollow sphere. Hollow sphere. The inside it is coated with the platinum black, and there is a small hole is present. Okay, there is a small hole is present. So that inside, so actually మనకి నార్మల్ గా స్పియర్ తీసుకున్నప్పుడు లోపల హాలో స్పియర్ ఇన్సైడ్ మొత్తం ఎట్లా ఉంటుంది, ఆటోమేటిక్గా వెరీ డార్క్. సో వెరీ డార్క్, దానికి స్మాల్ హోల్ చేసినప్పుడు అంటే ఇక్కడ మెయిన్ బ్లాక్ బాడీగా వర్క్ చేసే పర్ఫెక్ట్ ఆబ్జెక్ట్ ఏంటంటే అవుట్ సైడ్ కాదు, ఇక్కడ ఇన్సైడ్. ఈ హాలో స్పియర్ ఇన్సైడ్ మనకు బ్లాక్ బాడీ లాగా వర్క్ చేస్తుంది. సో అవుట్ సైడ్ మెటీరియల్ ఈజ్ నాట్ ఇంపార్టెంట్, బట్ ద ఇన్సైడ్ థింగ్ వర్క్స్ యాజ్ ద బ్లాక్ బాడీ. That is also not 100%, which is near, it works as which is near to black body. So next, so now we have to observe our topic is black body radiations. So black body radiation means the radiations emitted by a black body. Okay, so radiations emitted means if you, for example, if you heat any solid, a solid heat chestna, even if you heat the gases also, heat చేస్తే డైరెక్ట్ హీటింగ్ ఆర్ బై పాసింగ్ ది ఎలక్ట్రిక్ కరెంట్ పాస్ చేసి లేకపోతే డైరెక్ట్ హీట్ చేసిన సమ్ ఆఫ్ ద రేడియేషన్స్ మీన్ నథింగ్ బట్ ఏ టైప్ ఆఫ్ లైట్. ఓకే, సమ్ ఆఫ్ ద లైట్ రేడియేషన్స్ ఆర్ ఎమిటెడ్ అవుట్. సేమ్ అది మన బ్లాక్ బాడీని కూడా హీట్ చేస్తే ఆటోమేటిక్గా ఇట్ ఆల్సో రిలీజెస్ radiations, simply they are known as black body radiations. Okay, so for example, if it is heated, with the help of a burner, so automatically the surface heat చేస్తున్నట్టే the inside part will be also heated. So heat system, we know that it releases, okay, the inside body also releases some radiations. Our radiations out avvadaniki, our radiations outside ravali మనం వాటిని అబ్జర్వ్ చేయడానికి. That's why we use it a small hole. అందుకని స్మాల్ హోల్ ఉంటేనే అది ఇన్సైడ్ బ్లాక్ బోర్డ్ లాగా వర్క్ చేస్తుంది. స్మాల్ హోల్ లేకపోతే బ్లాక్ బోర్డ్ లాగా వర్క్ చేయదు. ఇట్స్ నాట్ లైక్ దట్. పైన హోల్ లేకున్నా కూడా ఇన్సైడ్ ఉన్న బ్లాక్ బోర్డ్ లాగానే వర్క్ చేస్తుంది. బట్ వై ఈ సపరేట్లీ మెన్షన్ అబౌట్ ద హోల్ అంటే, సో దీన్ని హీట్ చేస్తే automatically inside the black body, we know that the black body here is not outside of the sphere. This inside treated as a black body. This releases, on heating, it releases some radiations. The radiations are exactly released out from the hole. From the hole, pinhole means very small hole. So they are known as, these radiations are known as black body radiations. It's known as black body radiations. Okay, so now we define it. So the radiations, emitted from black body on heating it are called black body radiations. Okay, so actually the black body radiations, the released radiations from the black body are having not exactly a simple wavelengths. They are having the many types of wavelengths, and wavelengths mean nothing but frequencies. Mean the released radiations are not belong to any one region. They belong to different types of regions. Different type of regions ante mean they do not release only X-rays, they do not release only UV rays. So they consist of many types of radiations. Okay. So the radiations are of having different wavelengths, nothing but, or in terms of, we can say, frequency. Okay, so there is a different type of wavelengths, and automatically there is a different types of frequencies here are also present. So after observing the radiations, obtained from the black body, there is a picture is given which exactly gives the information about the relation between intensity of the emitted radiation and the wavelength of the emitted radiation. Okay, so have a perfect graph. So actually this is a very important one. So here on the y-axis take intensity. Okay, intensity on y-axis. So this is wavelength. We know that wavelength is lambda. So So after the study of black body radiations at different temperatures, already we said radiations ever release on heating to the object. So black body kuda heat cheste it releases different types of radiations. So they done the experiment and released the black body radiations at and they observed that radiations at different temperatures. Okay, and ఒక temperature దగ్గర వచ్చిన black body radiations they observed, and after some time they heated some more. So at different temperatures they absorb the black body radiation, and the information gathered is, so if you draw a graph between the intensity and lambda, so it is observed that so the graph is like this. So actually this is observed at 3000 Kelvin, so very high temperature. So see at the it is very important to understand the graphs. To understand the graphs related concepts is very important, not only in this chapter, in all chapters, not only in the chemistry, in the physics also. There's many graphs are there. With the help of the graphs we are able to understand some concepts. Okay, so if you see the height indicates the y-axis paina manaki intensity undi, y-axis paina intensity undante the height indicates the intensity. So x-axis paina undi manaki wavelength, x-axis paina wavelength undante so ఈ distance ఇక్కడ ఈ horizontal distance ఏం ఇండికేట్ చేస్తే మనకి wavelength ఇండికేట్ చేస్తుంది, ఈ vertical distance దేని ఇండికేట్ చేస్తే intensity ఇండికేట్ చేస్తుంది. So can you say at which the intensity increases? So for example, if you take here what is the height? Height is very less. Height is very less means intensity is less. Intensity is less, the height is less, intensity is less. So ikkada so right side lambda is also x-axis pena value kuda less, and at less lambdas the height is also less, means at lower wavelengths height is also less. See, in the same way observe the highest wavelength and horizontally wrong, right side. So here highest wavelength, the highest wavelength దగ్గర height is also very less, means we can observe that at lower wavelength and at higher wavelength. So lower wavelength దగ్గర height తక్కువ ఉంది, higher wavelength దగ్గర కూడా height తక్కువ ఉంది. So height then indicate చేస్తుంది intensity, means the intensities are very low at lower wavelength and higher wavelength for black body radiations. Next it is absorbed. So ఎక్కడ స్టార్ట్ అయింది, ఒక మిడిల్ వాల్యూ, ఒక అప్రాక్సిమేట్ వాల్యూ వచ్చిన తర్వాత హైట్ ఇంక్రీజ్ అయింది. సో నెక్స్ట్ ఒక లెవెల్ వరకు సో అట్లా స్లోగా ఇంక్రీజ్ అయింది. ఇట్ ఇంక్రీజ్డ్ అప్ టు ఫర్ ఎగ్జాంపుల్ ఈ 3000 కెల్విన్స్ దగ్గర సో ఈ పాయింట్ దగ్గర హైయెస్ట్ ఉంది, అంటే ఈ పర్టికులర్ వేవ్ లెంత్ దగ్గర, సో ఈ పర్టికులర్ వేవ్ లెంత్ దగ్గర దిస్ మచ్ ఆఫ్ ఇంటెన్సిటీ ఉంది, హైయెస్ట్ ఇంటెన్సిటీ ఉంది. సో దెన్ ఇంకా లాంబ్డా ఇంక్రీజ్ అయింది. సో ఇక్కడ లాంబ్డా ఈజ్ వెరీ లెస్. సో లాంబ్డా వెరీ లెస్ దగ్గర హైట్ లెస్ ఉందంటే ఇంటెన్సిటీ ఈజ్ వెరీ లెస్. సో రైట్ సైడ్ పోతా ఉంటాయి, రైట్ సైడ్ వాల్యూ ఇంక్రీజ్ అవుతుందంటే లాంబ్డా ఇంక్రీజెస్. సో as the lambda increases, intensity is also increases and reaches to the maximum. ఒక highest value reach అయిన తర్వాత సో ఇంకా lambda value increase అవుతుంటే there is a decrease in the intensity takes place. Okay, so we can observe the 2 points here. So at lower wavelengths and at higher wavelengths, at lower lambdas, at higher lambdas, the emitted radiations are having less intensity. Next, as wavelength increases, the intensity also increases to reaches a maximum value. Then after increase in the lambda there is further decrease. In the lambda takes place. Okay, these are the mainly 2 points we can observe by seeing the graph. Now here this is about the one curve. So for example, already we said the black body radiations are absorbed at different temperatures. For example, the same black body radiations are observed on overheating. So 3000 Kelvin kaakunda, for example, if you take 400 Kelvin. So if they take 400 Kelvin, so it become like this. So means so it is observed that as temperature increases, intensity increases. There is no doubt. As temperature increases, intensity increases. But so for example, the first time ఈ 3000 Kelvins దగ్గర highest point ఎక్కడ వచ్చింది అనుకున్నాం. సో ఈ పాయింట్ దగ్గర ఫర్ ఎగ్జాంపుల్ ఇఫ్ యు టేక్ x angstroms వేవ్ లెంత్ దగ్గర హైయెస్ట్ పీక్ వచ్చింది మనకి. సో అదే ఆ 4000 కెల్విన్ దగ్గర ఏమంటే ద హైయెస్ట్ పీక్, ద హైయెస్ట్ ఇంటెన్సిటీ ఎక్కడ వస్తుందంటే ఇట్ ఈస్ లెస్ దెన్ x angstroms దగ్గర వస్తుంది. అంటే ఇట్ అపియర్స్ ద లైక్ ద గ్రాఫ్ ఈ షిఫ్టెడ్ టు ద లెఫ్ట్ సైడ్. ఓకే, ఆ పీక్ స్టేజ్ అనేది చాలా స్టార్టింగ్ లోనే వచ్చేస్తుంది అనమాట. అంటే ఫర్ 3000 తో కంపేర్ చేస్తే ఇంకా లోయర్ వేవ్ లెంత్ దగ్గర మనకి ఈ హైయెస్ట్ ఇంటెన్సిటీ ఈజ్ అబ్టైన్డ్. ఓకే, రిమైనింగ్ క్యారెక్టర్ ఇస్ సేమ్. సో 3000 కెల్విన్ దగ్గర ఏ టైప్ ఆఫ్ క్యారెక్టర్ ఉందో 4000 కెల్విన్ దగ్గర అదే టైప్ ఆఫ్ క్యారెక్టర్. సో వాట్ ఆర్ దట్ క్యారెక్టర్స్ అంటే ద గ్రాఫ్ షేప్ ఈ సేమ్. సో గ్రాఫ్ షేప్, the curve shape same ఉందంటే automatically it is also having same thing. At lower wavelength and higher wavelength they are having low intensity. Next, as wavelength increases, intensity also increases to the maximum peak point, then further decrease takes place. But a peak stage అనేది ఏంటంటే 3000 Kelvin దగ్గర x angstrom దగ్గర వస్తే ఫర్ ఎగ్జాంపుల్ 4000 Kelvin దగ్గర it shifts towards left side. అంటే ఇక్కడ x వేవ్ లెంత్ ఉంటే less వేవ్ లెంత్. ఫర్ ఎగ్జాంపుల్ ఇఫ్ యు టేక్ 5000 Kelvin, సో ఇట్ వాజ్ లైక్ దట్. సో 5000 Kelvin పోతే సో పీక్ స్టేజ్ అనేది నా వెరీ లెస్ దెన్ 4000 లెస్ దెన్ దగ్గరే పీక్ స్టేజ్ ఈజ్ అబ్టైన్డ్. మీన్స్ as temperature increases the obtaining the maximum intensity is shifted to the lower wave side. Lower wavelength side means nothing but left side in the graph. Okay, this is perfectly observed in the for the black body radiations. Okay, for example, if you follow the classical theory, as temperature increases, so it is observed that so there is a continuous light takes place which cannot be equal to the zero, or which cannot be equal to the near to the zero. So this line is actually according to the classical theory of this black body radiations. Okay, but we have to understand this experimental black body radiation. This classical theory graph is just it is an imaginary one. So once again I will write. Okay, first we write the points. What points? Okay, first check the graph. You have to draw this graph. So it is intensity, so intensity is taken as y-axis, wavelength is taken as x-axis, so this is obtained at 3000 Kelvin. We know that as temperature increases, intensity increases, but the peak stage shifted to lower wavelengths. I can put it more. Okay, they are not exactly equal, so they are having somewhat left side moving. The peak stage should be moved towards the left side. So this is a 3000 Kelvin. So generally we taken as it T1. Okay. So this curve is obtained experimental, that is 4000 Kelvin, taken as T2 temperature. So this is taken as 5000 Kelvin. So that is T3. So generally in the problems they give you some symbols for this temperature T1, T2, T3, or from T1, T2, T3, whatever it is. The highest position is for highest temperature. Means what is the relation here is T1 is less than, T2 is less than T3. So this is this well explains about the behavior of black body radiations. So what are the reviews, the points we got by observing the graph is the curves reveals what are the main points. So just now we said a particular temperature, so at a given temperature the intensity of light of radiations emitted increases and reaches a maximum value that indicates about the peak value, then again decreases. With increase in the lambda value. With increase in wavelength. This is the main point which indicates if you see any curve, it is having the same character. So already we know the one more point that if you observe this any of the curves, we write the main point that both at the shorter wavelength and longer wavelength, both shorter and longer wavelengths, at shorter wavelengths and longer wavelengths, actually that corresponds to lower intensities. So actually this point is become a revolution at the time in the scientific world, because it is exactly opposite to the classical theory. Okay. So this point is contrary. Contrary means totally making a controversial statement, contrary to classical physics. The classical theory means the theories before this experiment. Okay, according to classical theory, so there is a continuous line is obtained at high temperatures. So it is just a dotted lines. That is according to the classical theory. So this point is exactly opposite to the classical theories of physics. Okay. Next, the curves are also reveals that as temperature increases, the curve shifts towards the as temperature increases, so the maximum intensity shifts towards the shorter wavelength, shorter wavelength. So there is a left side, that is the left side in the curves. Okay. Next, so one more important point I will say. So the maximum intensities, maximum intensities economic. So middle region at very lower wavelength height takku undi, highest means shorter wavelength height takku undi. So highest wavelength height takku means already we written the point that at lower wavelengths and higher wavelengths the intensity is observed is very low, but the maximum intensity is observed at average lambda values. Okay. So the last point we can write is most of the radiation is distributed with the some middle, nothing but average with medium wavelengths. Okay, the maximum higher regions, what the maximum radiations మొత్తం ఏ range లో ఉంటాయి, they are in the range of so medium wavelength, not exactly very low, not exactly highest. So middle range lone the maximum intensities are present. Okay, so this was about the what is the black body and what are the black body radiations. So actually there is a quantum theory is there, which is mainly given by the Max Planck, mainly to explain the black body radiations. Okay, now we see about the Max Planck's quantum theory. Okay.